Welcome back. If you are just joining the series, hi, we are doing a deep dive on sliding window patterns, one problem at a time. No skipping steps. We are on episode 8. Before I say anything else, I want to ask you something. Look at this binary array. It's just ones and zeros, nothing special. Now I tell you, you are allowed to flip k of those zeros. Turn them into ones. What is the longest consecutive run of ones you can create? That's the entire problem. No substrings, no frequency maps, no character counts. Just ones, zeros and a budget of k flips. And the answer, as you will see today, comes from a pattern you already know. K equals 2. Look at this array. Which zeros should we flip? Hold that thought. Let's build the intuition first. The problem statement is simple. Given a binary array nums and integer k, return the maximum number of consecutive ones if you can flip at most k zeros. At most k, not exactly k. You can flip fewer. Let's understand what k actually means. 3 examples. Watch how each one changes things. K equals 0. No flips. So your answer is just whatever run of ones already exists. 3 consecutive ones at indices 2, 3 and 4. That's your answer. K equals 1. 1 flip to spend. There is a 0 at index 1. Flip it and 2 separate groups of ones connect. 1 becomes 4. Notice what happened? You didn't just add 1. You connected 2 existing runs. That's the power of a flip. 1 0 removed from the middle can double your window. K equals 2. 11 elements. Flip indices 4 and 5. The window runs from index 4 to index 9. 0, 0, 1, 1, 1, 1. 2 flipped zeros and 4 ones. That's 6 consecutive ones. Output 6. K is not just a number. K is a budget. How do you spend it to get the longest possible window? That's what we are solving today. Here is what I love about this problem. If you have been following since episode 3, you already know almost everything. You already know 90% of this. I mean that literally. Episode 3 variable window. Shrink when the window breaks a rule. Expand right freely. The moment something goes wrong, shrink from the left. Let me go row by row. The rule. Episode 3 has a problem specific constraint. Episode 8 zeros in window less than equals k. What we track. Episode 3 depends on the problem. Episode 8 just one counter. Zeros. Shrink when. Episode 3 shrinks when the rule is violated. Episode 8 when zeros exceeds k. Loop structure identical. Same template. The only thing that changed is what we are tracking. Episode 7 needed a frequency map, 26 character. We had to know which ones and how many. Episode 8 binary array, only 2 values. We only care about the zeros, so we count them. Binary input, track one number, not a frequency map. That's the entire difference. The loop is identical. The shrink logic is identical. The only new thing is the validity condition, which is the next slide. I want this slide to feel like a relief. Zeros in window less than equals k. That's it. That's the entire algorithm in one line. Zeros in window is the count of zeros between left and right. A single integer. That's all you maintain. Valid as long as zeros less than equals k. Keep growing. Don't touch left. Invalid when zeros greater than k. Shrink from left until you are back under budget. This one. This is where people get it wrong every time. Zeros equals k is still valid. You shrink only when zeros is strictly greater than k. This valid, use it. This bug, off by 1 every time. One rule, 3 consequences. Everything else follows from this. Alright, let's stop talking about it and watch it happen. Say Mary, k equals 2. I have got L and R, 2 pointers. L is the left edge of the window, R is the right edge. Right now, both start at index 0. R moves right on every step. L only moves when something breaks. Let's go. R has moved across the first 3 cells. Index 0, 1, 2. All ones. The for loop runs. Each element, is it a 0? No. So zeros stays at 0. Zeros equals 0. K equals 2. Window is valid. Grow. Zeros with value 0 is less than equals k with value 2. So grow freely. L does not move. There is no reason to shrink. R keeps going. R moves to index 3. That's a 0. If nums right equals 0, zeros becomes 1. Zeros equals 1. K equals 2. Still under budget. Still valid. Keep growing. L stays put. 1 0 is fine. We have a budget of 2. R hits index 4. Another 0. Zeros becomes 2. Zeros equals 2 and k equals 2. Is it valid? Yes. Zeros equals k. Equal is still valid. We don't shrink until we go strictly above k. Zeros with value 2 equals k with value 2. Valid. Keep growing. This is the greater than, not greater than or equal rule. Right here in this moment. Zeros equal k and we don't touch left. R moves to index 5. Another 0. Zeros becomes 3. Zeros equals 3 and k equals 2. 3 is greater than k. Invalid. While loop fires. Now L has to move. We need to remove elements from the left side until zeros drops back to 2 or below. While zeros greater than k, as long as we are over budget, shrink. If norms left equals 0, zeros decremented by 1. If what we remove is a 0, bring the count down. Left plus 1. Move left forward regardless. Left starts at 0. It moves 0, 1, 2, all ones. So zeros does not change. Then it hits index 3. That's a 0. Zeros drops from 3 to 2. While condition is false. So L stops at 4. L has jumped to index 4. L equals 4 and R equals 5. Zeros equals 2. Back under budget. Shrink done. Zeros with value 2 is less than equals k with value 2. Valid again. The window is tiny right now. Just index 4 and 5. 2 cells. But it's valid. R can continue moving right. R moves to index 6. That's a 1. 0 stays at 2. Valid. Keep growing. And it keeps going index 7, 8 and 9. All ones. Zeros does not change. L does not move. The window just grows. R reaches index 9. Window spans index 4 to index 9. Best equals max between best and right minus left plus 1. That's 9 minus 4 plus 1, 6. Record best. Zeros with value 2 is less than equals k with value 2. So best equals 6. That's the answer. 6 consecutive ones. 2 zeros flipped at index 4 and index 5 and 4 ones beside them. Notice what happened across those steps. R moved right on every single step. No exceptions. L only moved once and only because zeros went above K. That's the algorithm. R expands freely, L repairs when needed. Best records the peak. R moved right on every step. L only moved once. Let's look at all 4 movements together. Movement 1. Grow. All ones. 0 stays at 0. Window expands freely. Movement 2. Still valid. Zeros equals k. Equal is fine. Keep growing. Movement 3. Shrink. Zeros goes above k while loop fires. L moves until we are valid again. Movement 4. Record best. Window spans index 4 to 9. Length 6. That's our answer. Shrink first, then record. The window repairs itself before we ever measure it. That's not accidental. That's what the code structure guarantees. Let's run this on LeetCode and see it pass. LeetCode 1004. Max consecutive ones 3. Not rereading the problem. One thing to note, nums.length up to 10 to the power 5. O(n) squared solution won't pass here. Sliding window at O of n. That's the move. Let's code it. 3 variables. That's our entire state. Left equals 0. This is the left pointer. Left edge of the window. Zeros equals 0. Zeros counter. How many zeros are currently inside the window? 1 integer. Best equals 0. The longest valid window we have seen. Updated as we go. For right in range length nums. Right expands the window one step at a time. If nums right equals 0, zeros incremented by 1. New element is a 0. Track it. That's all. Don't stop, don't break. Just count. Now validity. While zeros greater than k. While zeros greater than k. Not greater than or equal. Strictly greater. Write greater than or equal here and you shrink on valid windows. Wrong answer. If nums left equals 0, zeros decremented by 1. Removing a 0 from the left. Undo its contribution. Left incremented by 1. Move left forward regardless. When the while loop exits, zeros is less than equals k. Window is guaranteed valid. So best equals max between best and right minus left plus 1. Current length compare to best. Keep the larger. Return best. Now let's run the code. All test cases pass. Now let's submit. It submitted successfully. Let's go back. Same code. 3 things I want to name explicitly. 1 counter, not a map. Not 26 characters. 1 integer. That's the entire consequence of having binary input. Shrink loop only runs when something is broken. If the window is already valid, this never executes. It's conditional, not constant. This line runs after the while, which means by the time we measure the window, zeros is already less than equals k. The placement is a correctness guarantee. not a style choice. 3 ideas, everything else is just the template. Time complexity is often. Every index is processed at most twice. Once when right adds it and once when left removes it. No rescanning. Space complexity is O of 1. 3 integers, left, zeros and best. That's the whole state. Simpler constraint, simpler tracking. The complexity just reflects that. 4 edge cases. Know these before an interview. K equals 0. Every 0 immediately breaks the window. Answer is the longest existing run of ones. K bigger than total zeros. Window never goes invalid. Expands to the full array. Answer is length of nums. All zeros. Window stabilizes at exactly K. The shrink keeps pace with the expansion. Answer is K. This one. This is the interview trap. Zeros equals K. Valid. You don't shrink. You shrink only when zeros is strictly greater than K. Remember, strictly greater than K. So this one correct. This one bug. While zeros greater than equals K shrinks valid windows. Wrong answer every time. These are not tricks. They are all direct consequences of zeros less than equals K. Know the rule and you know all four. Screenshot this. Not for today's problem. For every variable window problem you will see. Left zeros best. Your 3 variables. For a different problem, zeros become something else. But there is always something here. For right, expand. If nums right equals 0, zeros incremented by 1. This is the update state on expansion. While zeros greater than k, repair when broken. If nums left equals 0, zeros decremented by 1, then left incremented by 1. So shrink and undo. Best is max between something. Record after repair. Variable window, validity check. Count, not map. Record the best. Next problem will have a different rule, different state, but always same skeleton. 6 problems, 3 templates, 1 pattern. Number 3, number 76, number 567, number 438, number 424. All done. Number 1004. Today, done. Character frequency, max frequency trick, 0 counter. 3 templates, 6 problems. You know all of them now. Different questions, same sliding window mindset. That's the sentence. Not I solved 1004, but I now think about problems differently. Episode 1 through episode 7 done. Episode 8 today done. Episode 9 practice set. All 3 templates together. That's where you find out whether the templates are in your head or just on the slide. We will pick up problems from each family and solve them cold together. See you there. That's episode 8. 3 things. Zeros in window less than equals k. One rule. That's the entire algorithm. Binary input means one counter, not frequencies. Same variable window loop as episode 3. Simpler constraint. Nothing else changed. If you took one reusable idea from today, that's what this series is for. Drop your solution in the comments. I genuinely read them. If something was not clear, tell me. That's how I make the next episode better. Learn smart, code calmly. See you in episode 9.